Hey, what's going on, guys? Chris here. So recently, this is another part. I've been doing videos about stuff I've been doing in my machine shop, and I've been doing a lot. I've been doing so many projects, it's kind of hard to stay focused when I'm in there because I'm bouncing from one thing to the other. And you know, I got the new mill, and then I did a bunch of stuff to the lathe. I got a new chuck for it. I did the variable frequency drive was already on it, but I just took off the pulley and all the other old pulleys that I don't use anymore for speed change. I took all that stuff off, took out the change gears, and did the lead screw, the electronic lead screw, and that's done successfully as of right now. So that's why I wanted to start recording again, because you know I've started recording several times throughout the process, but I wanted to show you guys it fully functional. And I probably should have done one during the electronics, but the Clough 42 is the guy who very generously shared his experience and his journey making this, because honestly the guy's incredibly smart, and you know, there's not a whole lot of people that are that intelligent left around, and the ones that are not really sharing their projects with the community. So I praise him for that. So and everybody should that has a lathe and would make use of an electronic lead screw. So I've installed that. I honestly, I haven't even closed that up yet, and there's no reason other than I went up front and I said, you know what, let me start recording right now. Matter of fact, let me just grab my screw gun real quick. I'll shut that and I'll show it to you. But yeah, this has been an experience. And then I've been making stuff on the CNC. I've been making stuff on the new mill. I've been you know, making parts for all this, and I still have a DRO. I changed the DRO on the lathe to an LCD. If you can't see it right now, I'll show it to you momentarily. And it's a lot nicer. It has a lot more features. It's a lot more beneficial. And then I also have another one similar for the mill that's all 3-axis. And then I also changed the scroll DRO to a better DRO that it tracks better. Oh, I need a tiny screwdriver because the encoder has been working out the little tiny screws. So I got to put like a little tiny dab of Loctite on them, because when it's vibrating, when it's turning, I'm going to make a more secure mount for it. It's a 3D printed mount, and I didn't know for sure if I was going to use it, so I didn't go crazy on the infill and all that. But I'm probably just going to design one myself and either I'll probably 3D print it, and then if it's not stable enough, I'll machine it. But once I do the design, it's easy. Oh, I need the little screwdriver. Once I do the design, it's easy to machine it, to change it from an STL to G code. And you know, do it. It's in Fusion. You can go right from Fusion to 3D printing, or right from Fusion to machining, milling. Okay, I have one teeny, there we go. One came all the way out, and then I noticed that, and it wasn't running for all that long, but just the vibration just worked these right out. I guess they probably weren't in all that tight. I didn't take it apart. Oh, so in the other video you guys saw, I was showing in the last segment, I was showing you guys the electronics, and everything was working, and then all of a sudden it wasn't, and the encoder wasn't reading anything. I don't know what happened with that. I actually had 3 encoders, because I got the one that I chose, which was a 2000 pulse per minute, pulse per revolution, CALT, C-A-L-T. That it's the same one I got now. I ended up sticking with that one, and then I got the one that James from Clough 42 recommends. I got that exact same one, and then I got one that came with the other lead screw kit that I got, that I thought the components were going to be good enough at least to use with his electronics, and that didn't happen. So I don't really know what what happened to the encoder. I did take it apart and I did see something burnt in there, but there was nothing. I didn't have anything hooked up that could have burnt it. I don't know what actually happened to it. I don't know why it happened to it, because everything's hooked up the exact same way right now, and it has been for some time, and it's not doing anything now. So I don't know, but I ordered a separate of the Clough 42 stuff that he sells, the electronics kit that has his daughter board and his interface, which I'm totally fine with. For a lead screw, for an electronic lead screw, you don't need anything more than the threads that you want, or if you just want it to feed and like those few settings, you don't need a touch screen. That's kind of ridiculous. I mean, I'm not even getting touch screens. They do have this thing, Touch DRO, and you can hook it up to any tablet you want. I'm not doing that. This is a workshop. I'm not, you know, I don't even bring my iPad in here because it's a workshop. I mean, it's just common sense. When he said that people were asking for a touch screen on the electronic lead screw interface, I mean, what do you need a touch? Don't you have your phone like right on you? I mean, we all do. There's no need for another touchscreen interface on something that you keep in a workshop that you're going to be machining metal on. That doesn't make any sense to me. So anyways, I didn't go out of my way for a touchscreen. I went out of my way not to get a touchscreen, in fact, because my hands are filthy right now. Anytime I'm doing anything in a workshop, you know, you get dirty. It's part of the deal. So why would you want to have something nice that you have to touch all the time to get it to work in a place where you're always dirty? It's just a bunch of things that don't mix. Anyway, so I ordered another one of his board and interface setup, and then I also ordered I ordered another this is a new encoder. I ordered another encoder, another TI board. I ordered I actually have a servo motor and driver, which is 12 nanometers of torque, 1700 inch-pounds. But I decided to try them both. The one that James from Clough 42 recommended and that he used in the end, which was a servo that has the driver built in, which is what you see here. And this is a NEMA 23 size, which is more convenient here because I don't have a lot of space. You know, inside the lathe. I mean, the lathe is big. It's like 30 inches long by 14. Those are the measurements, the cut width and depth. But I don't have a lot of room to play with inside that space as far as to give it up for stuff like that, for stuff like this. So what I think I'm going to do is I'm just going to cut a small hole in this panel so I can shut it, and that's going to stick out the side a little bit. Yep, that's what I'm going to do. I'm going to make a small hole right there, and I'm going to let the motor stick out, and that'll give more, let it cool more, and that's what I'm going to do. So, I mean, I know a lot of people are, oh my God, you know, I don't want to mess up my stuff, and you know, I don't want to mess up my stuff either. But at the end of the day, it's not something I'm planning on reselling, and it's also my workshop, and it's my stuff, and it's my building, and it's my property. It's my property, literally property that the property's in. And I'll do what the fuck I want. It's that simple. I want to cut it open because I want it to have more air, and because frankly, it is a workshop. It's a workshop. That's the punchline. That's the point that needs to get across to people that are so anal about things like this. We're in a workshop. Yeah, I have nice stuff too. I have really nice stuff. I mean, this chuck is like a $400 chuck, just the chuck. Not the plate, not anything else, just the chuck. I have nice stuff too, but you know, it's workshop stuff. It's made to be able to take a beating. I mean, it's made to be able to withstand a workshop environment, and that's what we're in. So anyways, moving on. I got a new, basically everything, so that I could replace any components if I need to. I'm going to show you really quick the electronics enclosure that I made. This was an enclosure that was on the wall here in my building that a former tenant that had. It was either from the alarm system. I have an alarm system, a new one, but it was like they had an old school wired alarm system, or it was from the old school intercom and electronically locked doors with the key cards. It was from one of those two things, but it was a good size metal box for an electronics enclosure, and it worked out perfect. I'll show it to you now. It's right here under the bench. So let me see what I'm showing you. All right, so you see I got a 48, it's up to 60 volt power supply. I have it on 23.5. And then I did have a buck converter to give 5 volts, and it was working fine, but I ended up finding, if you remember, I think I mentioned I hadn't been able to find a 5 volt plug-in connection with a barrel connection, and I ended up finding one. And I also have a couple of 5 volt DIN rail power supplies. I thought about putting a little piece of DIN rail in there and putting a 5 volt power supply, or just leaving the buck converter, but then I just ended up doing this, and that's what I'm doing. And then, so there's a filter on the way in, and then it before the filter even, it goes to the momentary switch right there, and this one's for the lathe, that one's for the did I label that one? No, I didn't. That one's for the electronic lead screw. And then I put obviously a 24 volt fan blowing out, which I'm going to change to a Noctua. So I'll put a little teeny voltage reducer to make that 12 volt and put a Noctua fan, because that's kind of loud. And then I'll put, not that I'm probably going to even care in here or notice, but I have the Noctua fan, so why not? And then I put a little cable raceway that I had left over to keep it nice and neat. There's only a couple of loose wires that come in that are going to stuff. And then I ran the screen wire up, and it goes through the lathe and out to right here and into the back of that. That's just I actually did get, if you guys watched Clough 42's video, I did get the bud box, the aluminum bud boxes that he used, that he machined. And I may machine it, or I may just open it up and put that in it, but I am going to put it in the aluminum bud box. I have 2 of them, so that's the plan long term. And then I put the switch, and I filtered everything and wired everything nice and neat. That's the new digital readout, and this actually has a tachometer on it too, which I had to set up right here. So this is a piece of the what I made for the x-axis that I'm going to show you, the guy that has the video who designed it, and I printed it. And this is a piece of the coupling that joins the 2 shafts, and I just bored it out to be the size of my shaft and made a keyway for it to fit my key, and it lines up with the pulley. And I got that new pulley, and it goes straight to here. Took the other one out. I could take this idler out. I haven't taken that out, obviously, but, and then this right here, I just bent a piece of you know, I think it's like a 1/4 inch sheet steel. I bent that and put it so that the sensor is, it's a hall sensor, obviously. It was the right distance away from the magnet that's under the under the electrical tape on that piece of 3D printed coupling. And then I put the pulley right after that on the end of that shaft, and that goes right to right here. That's the encoder, and it's on a 3D printed mount that is bolted through a big block of aluminum, because I needed to space it out that far. And instead of making 2 little spacers, I just machined that piece of aluminum down to exactly how far out I needed to be. And I drilled out two 8mm holes, and then I lined it up and put 2 7mm holes in the cast iron, and then tapped them for M8. And it worked out perfect. It's very secure. And the stepper motor, the servo motor, it has a motor mount on it, an aluminum motor mount that tightens down onto a circular object, like that piece of aluminum that I machined down, and that's what it's crimped onto. And it actually is very secure like that. It's surprisingly secure. It's impressively secure. And then this is actually a perfect diameter. I couldn't even fit the key. I could have made a keyway. I think I mentioned I did get a keyway broaching set because I watched that girl Blondie Hacks video, and she was showing these, and I got interested in it, and I said, you know what, it would be really nice to have one of those when you have to do that. So here we go. I bought one, and it's a pretty good one. These are actually very expensive. This was like $600. So it's surprisingly expensive. I mean, it goes bigger than I'm probably ever going to need. I probably could have got the smaller set, but I mean, if you're doing it, do it right. Just because that one time you don't, you're going to need something else, and you know, you're going to need it. That one time you need it, I'll be kicking myself in the ass that I didn't get the good one. So yeah, I've been going kind of all out in the workshop. But the tachometer works great. The lead screw, electronic lead screw works great. I'm going to show you real quick. Oh. So there's my speed. There's my speed there, and that. Oh, I gotta reprogram this because that's got double the speed. That's not almost double. I have to change that. There's something, I'm not sure what's off about that. I'll have to look into that because it's not at 1050. This one is accurate. Matter of fact, I'm gonna get my little laser tachometer. I have one in here, and then I already have laser tape on the lathe chuck. Not the plate, but there's two parts that mount the plate. There's two parts that mount the plate to the the back of the shaft, and they screw in, and then they're kind of like pitched, so they kind of like pull in, even though it's already threaded in tight. It pulls it in even tighter. It really like locks the lathe chuck in, and it's actually, I think it's a really good thing to have. I'll show you. You see right there? So that's the reflective tape that I'm going to measure the speed with, but right there, see how it locks it in? I love that it has those. I think that's so awesome. Even the other lathe chuck plates that I got for the other chucks that I got, I made the holes for those in them. So they all are threaded and tapped for those. But yeah, that's my 8-inch and my 8-inch chuck plate. And those are 6 and 5. And I got rid of anything smaller. And then that's a table that goes up and down. It's like you can have another axis with this, and you can actually do like milling. You can actually do some milling with it, or milling type operations. So yeah, it has a little vise and it moves up and down. It's convenient when you need something like that. So I'm going to show you real quick here. See what speed is most accurate. Oh, turn this thing on. What am I going to do? Laser. You can also touch it here, and it'll do it that way because this will spin. But I think I'm going to do laser. Yeah, we'll do the laser. So 890, and this is saying 735, and that's saying 1138. So neither one of them is accurate, or this one isn't. I don't know which is wrong. Oh, you know what? I think this is going to be off. Hold on. Let's see. You see I have a piece of reflective tape there? Oops. There's one on both. That's gonna give me a double reading. All right, that should be good. I took that one off. Yep. So I'm at 449 RPM. Yeah, 450. That sound, it's doing 450 right now. So whatever this is, I have to configure this to be set half of what it is. That's or actually like a third. So I did a 3-to-1 gear ratio, but I am using a 3-to-1 gear ratio. Look at the 2 gears on the drive. It's a 3-to-1 ratio. I mean, it's 1-to-1 on the it's 1-to-1 on the encoder, so that shouldn't make a difference. I really kind of wanted to put this motor couple it right to the shaft, right to the lead screw. And I've seen other people that have done that on their videos, and somebody did it on this side, and I could have done it on this side. What I was going to do is I was going to take that bracket off, and I was going to take the bolt off, and I take the bracket out over to the mill and mill it down like a substantial amount, so that I could have that bolt go down further and have more of it to couple to, and then couple it right to that bolt from the shaft, and then just make a mount for it, or put it in like a standard L bracket motor mount, and then make a mount for that, you know, to secure that from the table. And I still may change it up and do that, because I think that would be like by far the best way to do it, because that's as direct drive as it gets. You know, I mean, 3-to-1 and calculating for it could probably be as good, but I mean, you're never going to mess up straight right onto the shaft, one shaft to the other. I mean, that's as accurate as it gets, because it's the same damn speed. So I'm going to show you, there's some settings in here that I can go to for the I mean, this DRO is pretty cool. It's actually not very expensive. I got this for $380 with 2 scales. Let's see, and then I'll show you the other one for the mill. Oh, and I got my Z-axis done. I did that myself. And then today, of course, when it's done already and everything's done and wrapped up, I got the set from Priest Tools, and I ended up talking to the guy. I was like, listen, I'm sorry. I was gonna try to be compassionate and keep it and install it, but I've already put so much time into doing the X and Y, and it's done. And now I got to install the DRO, and I really don't want to add to the list of what I need to do after doing that and everything else I've been doing. And he doesn't even know the rest I've been doing. And you know, I apologize, but it's honestly, it's been like 3 weeks. I've already done it. He was fine with it. When I heard back from him, he was totally fine. But anyways, let me just keep showing you this. So RPM settings, okay, and we're gonna hit enter. And this is how many sensors. So there only is one magnet on here. So I'm not sure why this isn't accurate. There's only one magnet there. It's just right here. The bigger one is on the bottom. It's you know, you can see there's electrical tape, and that's holding the one magnet in place. I don't know, and it's supposed to be within 10 millimeters of that. Maybe it can go back a little bit. I mean, that's pretty thick steel that I bent over. I bent it in my ductwork brake. So, oh, and I 3D printed a gear, and this is conical because for it to go back and then to go engage with the gear, which I think engaging with the gear is a good idea. The only problem is that the encoder sticks out a little bit, actually a decent amount, and the gears aren't that far out. So even with this, it wasn't enough. It has to come, or you have to mount it the other way. But anyways, I'm happy with this setup. Everything's nice and tight. Let me just show it to you while it's not running, so you can see everything how it turned out. I've been obviously using it while I'm doing all this stuff because I needed parts. So it's kind of a mess, but you know, you can see that so this will be enclosed, and the ass end of this will protrude out a little bit, but it should only come out like this much, and that's really the part you want to cool. I mean, here's the cooling fins right here, so that's the part you want to cool anyway. So it probably is going to be effective for cooling, and it's the easiest way right now to have my side door be able to shut. And just I honestly don't even care about the side door shutting, but I do care about keeping these components safe and functional. So that's why I'm doing that. That's why I care about doing it, because I'm usually more about function than about aesthetics. I do care about aesthetics, but just not as much as most other people, because function, as long as things function properly, that's my main focus, because I have to use them first and foremost. But anyways, and because I don't need to impress anybody. I don't really care what anybody thinks. You know, if people, especially not, I don't care what anybody thinks. I don't care what anybody thinks about how nice my stuff looks, or like how clean my truck is, or my shop, or whatever. That kind of stuff I don't care about. Because, you know, if they know me, then they know me, and then, you know, that's what I care about, is that people have a different opinion of me as a person, not as how well I keep my stuff, you know, or how nice I make my stuff, or whatever, how clean I keep my shop, blah blah blah. Okay, so yeah, that's it. So I'm gonna cut that hole out. Probably when I stop this video, I'll cut that hole out. And oh, I was showing you this. So it's only got one sensor, the switch on, and then the gear ratio, which I don't know why you would have a gear ratio for the RPM. Is it calculating? Do I have something? It isn't. Well, there is a gear ratio because it's a small pulley to a bigger pulley. It's probably 2 to 1. Let me change that and see if it does anything. Oh, that's probably definitely what it is. Okay, let's try that. How does that have me at 423 right now? Oh well, that's closer to this one now, but I'm not. That can't be 500 RPMs. Hold on. It's at 9.7 hertz. That's very. I mean, it's out of a 60 hertz circuit, but you can turn this up to 120 hertz. That's 167 RPM. Oh no, and then I just read 500 from. Is that 500 RPMs or 166? Let's see. That's 266. Okay, no, this is 266. So that's 4 times high. And that's 3 times high. Now that one's worse than this one. So maybe I needed to have that the other way around. Maybe the gears needed to be the other way around. Hold on. Oh no, yeah. All right, let's see what that did. Oh, that's much better. There we go. Now it's actually accurate. $263. It's pretty darn close. That's like within 50 RPM or so. Let's go a little faster and see what it says. Yeah, 4.9. Yeah, that's close. How about now? Yeah, that's well. No, it was at 1,000 before. Why did it slow down? Just knock something over. I'm at 15. No. 1039, so it's a little off when it's faster. So now I'm at 2,500, almost 3,000. Yeah, so it's not the higher you go, the less accurate it is. Oh wow, this thing had me at 5,000 RPM. This one had me pretty close to where I was. Oh, no, that's not the screw came loose, it's the box. That's not going to be on there for very long anyway, so it's no big deal. Oh, the electrical tape's starting to blow off. Spinning that fast. I'm blowing the electrical tape apart. Well, anyways, that's it's closer on this one at a high speed than it is on that one. This is a three-phase, 3 horsepower, 3-phase motor on here. It's an A.O. Smith. It came off of actually one of my rooftop units here when I bought a new rooftop unit, and I remember buying it because I managed this building for like 8 years before I bought it, and that was a $1,200 motor when I had to replace that blower motor on the rooftop unit. It was an old train rooftop unit, and that motor was $1,200 and almost $1,300 when I bought it. And it's I mean, you know, typically a blower motor in a furnace is not anything that would be enough power for this, but I mean, this is a 10,000 square foot building, and that's one of 4 rooftop units. So I mean, it's a big building, and you know, it's a big unit. It's a big HVAC unit. So yeah, now it's within 30, 40 RPM. This one is double to triple at low RPMs. So I gotta fix that. I gotta fix the calculations and the firmware. But if you guys bought and installed one of these, I'm sure you probably do know how to do that, because James from Clough 42 does a great job explaining it. If you look at the right videos and you go to his GitHub and get the right information, if you go and get the right information, you'll get the right information, because he does explain it very thoroughly. There's wiring diagrams, there's all kinds of stuff. Like he's putting everything on there, like assuming that you don't know anything. He was very thorough, and you know, obviously, I mean, I sure as hell appreciated it, because there was a couple of things that I didn't know how to. I mean, like the coding and the programming, I do know enough about to get by, and I'm sure I would have gotten that. But I mean, it was helpful to have the answers just given to you and not have to go through it and look for it. That was definitely helpful. But when I do stuff like that on my own and I have to figure it out, that's how I learn. That's how I've gotten as good as I've gotten at it. So I don't mind doing that. But for most people, they might not want to do that, or want to learn how to do it, or you know, they just want to see what you need to do and do it. So that's why I think it was a good idea that he did it either way, whether you do want to see it or you don't. The rest of his documentation is very thorough. Honestly, I can't believe he sells these for so inexpensive. This was like $50. It's only the daughter board, and you have to buy the main board, the Texas Instrument board, which is like, I mean, he says in the video that's 5 years old that it was $30. I mean, that was pre-COVID, so it's definitely not $30. It's like $80 or $90 now. So, you know, but that's, I mean, everything inflated like that during COVID, and then, you know, now they think it's okay to just keep them that price. Or, you know, they went down a subtle amount that you don't notice, but when they went up, it was so much that you really noticed. So anyways, I'll probably just bring my laptop back here and hook it up to the USB that way and do it right back here. Just because I don't want to have to pull the board out and all that. Now everything's working well, and I'll probably honestly leave a USB hooked up to it, so hanging out here, so if I ever have to change anything, I'll just be able to do that. But first things first, I'm going to cut that hole. So now I'm going to shut these two off. Boom, boom. And the VFD has a large capacitance in it, so it'll stay powered for a little while before it actually shuts all the way down. But I'm going to move these tools out of the way. When I'm done, I'm going to clean up all these tools and finally put them away, because the lathe is actually pretty much done. And then I'm going to bring you over to the mill and show you how I'm doing over there. So I still have the digital readout to install. I did do the Quill DRO I did replace that. And the other thing I've been investing in heavily is nobody likes not having a sharp, good drill bit. I mean, that drives me crazy. So I invested pretty substantially into some really good drill bits. I got a couple of metric sets. These are Chicago Latrobe, I think. It was like a $700 drill bit set. It's the big set up here. Not that little drill hog one, that one in the back. That big set. That was like approaching $700. So I got some good drill bits that'll last a long time, and I do have a drill bit sharpener, so when I need to, I can sharpen them. And then in here, I got a great deal. I got this bench for $100. Again, another one. The one in my other shop in the back has a bench identical to this, the upper bench, but that one was on clearance when I got it. And then this one also. I only bought this because I saw it with the clearance tag for $100. I was like, I get lucky twice with these. So, and then this is all drill bits, and I actually still have more coming. So this is all the way up to 24 millimeter, and then I have a large set in standard coming. These are metric in the back, and then these are standard up front. These are the Molly Benham M7. These are the silver and silver. I forget what it's silver and something. It's a very strong combination for larger size bits. And then these are just cobalt, and these are all cobalt up top. So they're all very good, very high quality bits, and they cut really well. So making holes with a dull drill bit and I've had times where I've had to stop and sharpen the bit multiple times in one cut, like one hole. And it's so frustrating when you can't even make a hole with a drill bit. It's so insanely frustrating. So, and for the mill, I've gotten, I got this is one of the facing bits I already had for the CNC, but I just got an R8 chuck for it, an R8 shaft for it, or an R8 arbor for it, rather. I can still put it into the CNC machine. This has the different collets. I forget what they're called. They're like R30 or something. And that is the mount that goes into, if you can see it, going onto that facing bit. That's a 3-inch. So that's what I was just reducing the height of that aluminum with. That's mainly for aluminum, especially with what's on it right now for blades. That's for aluminum. But it does a hell of a job facing aluminum. I can take big bites out of it. So this machine, the next thing I'm going to do back here when I'm done with this digital readout is I'm going to lift the Z-axis on this. I'm going to buy two 2.5-inch thick by 5-inch by 5-inch squares of either cast iron or some kind of steel. And I'm going to machine them in that machine for that machine. I'm going to machine them in that machine because I already have the CAD drawing. I already have everything. I just have to do the machining process, but I have it in CAD. And all the measurements are correct. Everything, I've double and triple checked everything. Everything is exactly the way it needs to be to mate with the top of the underside of the gantry and the top of the gantry mount. So it should seamlessly give me 2 inches addition. Hey guys, what's going on? Chris here. So I wanted to make one last segment about the electronic lead screw setup. So I've gotten it pretty much finalized with what I want to do. I got the encoder mounted the way I wanted. There's no more 3D printed mount, and you know, obviously everything is. Did I use anything 3D printed? No, the only thing I used 3D printed was the piece of the shaft, the shaft linkage for the X-axis motion on the mill. I used a piece of that shaft linkage, one of the ones that actually didn't print, you know, properly, and I had a part that did print properly. I used that to sink a magnet into for the tachometer on the DRO, the DRO, the new one that I put on. So right now I'm just doing a debug flash. If you guys have done this before, then you know what that is, but a debug flash is just like, it's a temporary Not temper. It's until you shut it off. So you see how it just said Clough 42 on there. It's gonna update. These headphones aren't for this. I just was listening to music before. It's gonna put it on the RAM rather than on the flash drive on the chip, on the Texas Instrument chip. So it's until you shut it off. It won't affect what's already programmed in there. But what was already programmed in there, the problem I've been having is I have three encoders back here with me right now. I have these two and then the one in there. So I didn't get the one that he had used and recommended in the first place. I got actually a better one. This was like double the price, and the resolution is 2,000 pulses per revolution. So that's why I got it for the higher pulse per revolution, because it's more accurate. The more pulses per revolution you get, that's why it's more expensive. So it didn't end up working out because it's limited in the firmware up at 10,000 pulses per revolution, and with a quadrature there it's really 8,000 on two. But at 8,000 it was closer. Like I was getting readings of 2,500 RPMs at 200 RPMs. 24 something, and I actually sent them photos where you could see this tachometer, as well as this little digital tachometer that's an optical tachometer right here with a magnetic strip on there, and I have the physical part for it, and the readings were all the same in multiple, on 4 different ways of checking it at the same time, but they were. This is always a little bit off. The tachometer up here is like, I don't know, 50 to 100 or so RPMs off. But this was being way more off than that. So I had it set to 10,000 with this. Then I got 2 different manufacturers of the same model number encoder that he used, that he recommended. The MR-1 one, which is the one that he had in the photo in his GitHub documentation, and I have one of it here. This is the exact same one. The MR-1, that's the exact same one from the photo. And then this is another brand that's a little bit more reputable of a brand. It's BERM, and it was a little bit more expensive. Nothing crazy, but it's a more reputable company. So, but it's the same exact model number. Nothing. The only difference is the manufacturer. Anyways, when I first turned it on, I went all the way up to 10,000 in the resolution in the firmware settings, in the configuration, and at 10,000 it was almost dead on when I switched to this encoder, which was strange because this is a 1024 pulse per revolution, like the one that he used, and it should be too high. That should be too high. I'm not sure why I'm getting, and I've got it, it's really securely mounted. I finalized the mounting and everything. I'll show you. Hold on, let me take you out of here and turn this so I can see what I'm showing you. Hello. Am I tightening it again? There we go. No. Hello. All right. So you see I got my laptop set up down here. This is my little electronics enclosure for everything. I haven't run the wire for the encoder properly. It's just hanging out the bottom. I'm just testing with it, obviously, at this point. So this is how I mounted the motor and the encoder. And obviously the magnetic sensor, the Hall sensor for the digital readout. And then I did just a straight pulley from there's no reason to have any timing belt going to a second pulley to gear reduce it. It's going on a variable frequency drive. I can change the speed at the turn of the dial, and it's a huge motor. I mean, this is a big 3 horsepower A.O. Smith 3-phase motor that was in a furnace, a rooftop HVAC unit, a furnace and air conditioner on the roof of this building, and I had put it in and bought it the year before. I ended up replacing all the units because I had bought the building that year, and the old owner didn't want to buy the new units. He just wanted me to fix it, which that thing was $900 and change. So it's a beast of a motor, and it does like a 3,500 RPM. So with a straight belt, it's doing. I've actually had it higher than that, just seeing how fast it would go. But anyways, so to mount that, to mount the encoder, I did 2 GT2 pulleys, 1-to-1, same size. And I machined out, I cut that piece of aluminum, and I bored out, and I drilled and countersunk the M8s that mounted to the frame of the lathe, and then I drilled and tapped 2 M6 for the mounting bolts, the little button heads. And then I did the two, this one I used my new keyway broach to make this. I had to bore this diameter the exact same, you know, in the exact same spot, but the same diameter as this shaft, which is 3/4 inch. And I had to make a new keyway for the key on this. So I got to use the keyway broach. It works great. And that's it. So it's a 1-to-1, you know, on a 10mm GT2 450mm closed loop belt. And then this is the same servo. I just turned it so that the wires are facing the back, and I just cut a hole for each of them. Well, I actually had the servo the other way. I had it sticking where the spindle or the pulley was facing inward. So the back of the encoder was sticking out, and it was coming out that hole right there. So, but now it's not gonna have to, obviously. So that was a waste. Obviously I used my plasma cutter there and made it quick and easy, but it's all good. I'm not worried about it because this is my lathe. It's not going anywhere. But anyways, but the stepper still, the servo still sticks out. It's, I mean, I don't care. It doesn't bother me at all. I know a lot of people would not like that, but I mean, I have these tools to use them for their function, not for their, you know, aesthetics. I mean, I don't want it to be ugly, but to me, that's not really that ugly. I mean, I did the box for the screen, and I did that all pretty. I did the same thing with this one, you know, and my little holder for the and oh, that's actually the same guy that had this, the L-shape. I used an old Craftsman 1-inch because that's where my bolt is right there, and I you know, used the oxy and acetylene and put it in the vise and just bent it, heated up red hot and bent it. Very simple. And that's the boring bar from boring out the pulley right there. So I don't know if that was that pulley though. I think I did that one on the mill, but that was one of the other pulleys, maybe for this. So, and then this is on a motor mount that has, it tightens down on that cylindrical thing. It's actually, it was supposed to fit on here. This is what it's supposed to fit. It doesn't fit it. So I just made a piece that it does fit, and I bolted that in with an M8. I drilled and tapped the M8, and I put an M8 long socket head cap screw. You can see it sticking out the front, and that's Loctited in there. It's tight. It's tight. It's very tight. And this thing is not. It's not moving. Like, I mean, I can move the machine by it. So, and the belt's tight as hell. You know, it's not over tightened, but it's very tight. So right now is going to be the first time I'm testing it on 8,000. I put the settings to. Let's see. Let me go. Oh, it's running, so I can't look at it right now. But let's test it, and then I'll stop it and see. Because if it works, I got to change it to a release version. If not, I got to change the settings. See how smooth it's running now? It's running great. Oh, well, look at that. Look at this. Look at this. That's 475, 487. It's pretty damn close. All right, let's see what the jury says. 570. Build it as a release. There you go. And then I'm going to flash it as a release, and that'll be, I won't have to flash it again unless I need to change something. But every time you need to change a configuration setting, this is what you have to process. I mean, it's no different than any other electronics firmware. Yeah, like in 3D printers, you have to do this with Clipper. You make a change, you have to, you know, save it and restart it. It's just what you have to do. But with that, at least you can SSH into it. It has Wi-Fi. This is not. I can't do this from my small workshop, or even from my. Well, I could run a USB to that computer, my CNC computer. Okay, that's built. Okay, let's flash that. For real now. Okay, that's gonna flash it. It's gonna erase the drive and then flash it. Oh, sorry, you guys can barely even see what I'm doing. Anyways, I'm just on that same laptop, just making that same flash that I already did be on the actual flash drive instead of the random access memory, and save it on there for real, so I can shut this off and disconnect the computer, because within 20 RPM, I mean, there's got to be a margin for error on that digital on that laser tachometer. as well. So I mean, it's pretty darn close. I am going to look into any documentation I can find, and I'm going to see if there's a way I can find out exactly why I'm getting readings that are so far from, like, there's got to be a calculation that I'm not doing, that I don't know that I need to do, because I'm everything logical as far as the quadrature encoder and you know, the 4 times multiplication for that, and you know, the actual pulses per revolution and that I'm calculating. I mean, I'm taking everything into account that I know of. So unless there's something I don't know of that I'm obviously not taking it into account because I don't know of it, then that's the only thing, the only variable that there could be, really. I mean, I've taken everything else into account, like I'm saying. So we'll see, but I'm gonna try threading with it once this is ready. Okay, resume. Okay, done. All right, now let's put this bar in here. It's just a scrap aluminum. Well, it's not actually scrap, it's brand new stock, but I started cutting it already, so I'm just gonna try to thread it. I'm just gonna do an 8 TPI because I actually have something that I have to thread 8 threads per inch. It's for the, I have a lathe chuck plate for my 8-inch lathe chuck that I need to thread 8 threads per inch after I bore it, because it's a 1.5 inch bore and my lathe has a 1 3/4 inch bore, which is odd because my lathe is, it's big. It's not, it's like 30 inch by 14 or whatever. So it's a pretty big lathe. It's like a gunsmithing size lathe, but I don't think they standard have, I mean, pretty standard is 1.5 inch. I don't think, I mean, it gives you a bigger diameter to get the material through, which is beneficial for sure, which is why I wanted a bigger lathe chuck. That's the first reason why I did. There's a lot of other beneficial reasons to have one, but the first reason was to have more access to the center, you know, to to the center hole, to have larger material go through it, because it's definitely helpful when you can put a longer piece of material through there and then have it come through the chuck out the other side. Okay, we're flashed, we're done, we're ready to go. I can disconnect this. All right, you're coming out. Yep, I know, you can get mad at me if you want for disconnecting you without closing everything, but it's flashed and I don't need you anymore. Sorry, I know, I'm a dick. I don't think my computer is actually going to get mad at me. All right, you're done. Let's get this out of here so it doesn't get destroyed. Okay, I'm surprised it survived this long in here. All right, let's see what we got. Let's see what we get. So I'm gonna just test the speed one more time. Make sure that went through the same way that I had it just now. Yeah, it looks like it did. .588. Yeah, it's pretty damn close. It's within 20 RPM. So that's pretty good. I'm happy with that. All right, so let's see how that works. And yeah, you see this is moving. I mean, this can actually, I did test this for the power of the motor. I had this going at a quick feed with a deep cut, and that thing does not slow down. And that's a high torque HT5 belt, GT5 belt, HT, whatever the acronym is. It's something similar. It's like a high torque application or high torque something, but it's a GT5 is the spacing on the timing belt. So let's see, I can get pretty slow RPMs here, obviously. That's 95 or 110. It's probably, well, I don't know at this speed. You know what? I'd like to know what I actually am going at the really low speed when I'm trying to thread. .112. Wow, that's really close. Okay, that's within 3 RPM. I think I can live with that. Yeah, this is going to stay the way it is. Okay. I'm very happy with that. So let's let's give this a shot. All right. All right, so I'm going to do a, let's see, I'll just do a small initial cut. Okay, maybe a little more than that. Okay, ready? What the hell's going on? There you go. Oh, what the hell? I didn't turn it to thread. Hello. Oh, I have to stop this first. That's right. Thread, and I need to go to 8 TPI. That was pretty dumb. Okay. Set. No settings. Okay. Well, it's on 8 TPI. So let's turn this back up. Oh. 178. Okay, that's good. And it looks like that one up there is more accurate at that speed too. All right, so let's start this. Is that right? Oh yeah, there we go. All right, now I'm gonna go, that's a good amount deeper. You see how much power, how much torque this motor's got? It's got a lot of torque. I mean, it's aluminum, but it's still, I'm going pretty deep. Yeah, that's even deeper. Let's give that a shot. Oh yeah, that thing's got a ton of torque. And it's right on the same, thread. That's actually very good. Wow, okay. It looks like more than 8 TPI to me though. So I don't know if that's right. I'm gonna have to find out. I'm gonna have to measure it. But it does look like more than 8 thread per inch. It looks like finer threads than that. So if that's my worst problem, it's just some configuring and I'll get it right. But I mean, it'd be nice if I had it right now because everything's working right. All right, that's pretty deep. That's a big cut too. Yeah, that servo's got some balls, man. All right, let's see what they look like. Well, yeah, it's repeating. I mean, there's a couple of spots where you can tell it's not exactly in the right spot, but they're not. I mean, they're pretty insignificant. The threads are threads, but that is not 8 TPI though. That's like, I don't know why that's so high. That's like 20 something threads per inch. That's more than 18. Yeah, 20 is not even enough. That's a lot of threads. I don't know why I'm getting so many threads. It's set to 8 TPI. I mean, it says 8 TPI. I'll have to look into that. Maybe I got the lead screw information wrong. I mean, my lead screw is the same as his. I mean, this is a Shop Fox, and Grizzly owns Shop Fox, or they do now. And his is a Grizzly, and it's I think his is a little bit smaller than mine, but it's pretty close. It's pretty much the same thing. I've seen it in his video. His lathe is like the way it's set up, the way the motor is, and all the pulleys. It's almost exactly, and the castings are identical. They literally, you could probably switch one out for the other. I bet you they were made in the same factory. Well, I think it might be a 28. I think that came out 28, not 8, 28. Yeah, 32 is too much. It's less than 32. I think it's 28 looks right on. It is. That's 28 threads per inch. Why is that 28 threads per inch? I have to figure out what is not right here. I mean, if that's 28, then what am I going to get when I do like 20 threads per inch? Let's give it a shot. Screw it. I have another diameter here on the beginning part. All I have to do is loosen this and then push the live center back a little bit so I can get the cross slide back further. Oh, I gotta loosen that. And not enough? Yep, that's enough. Okay. All right, let's try that and let's see what happens for the hell of it. I'm gonna try it at a little higher speed. Well, maybe 400 is a little much. Let's see. 300, yeah, let's try 300. Oh, what am I doing? That's at 0, hello. Was it 0? Okay. Wow, these scales are really sensitive. I mean, that's a good thing, but all right, let's go in a little bit. Holy mackerel. Oh my God, that's like, yeah, something's definitely off. That is like 1,000 threads in an inch. Holy shit. That's not 1,000 threads in an inch, but that is a lot of threads in it. That would be, I wouldn't even be able to count those. That is ridiculous. I don't think I've ever seen something threaded that fine. So I said there's something off with my I don't know what. I don't know what. Maybe, I mean,